Hello students and viewers, this is a Teta from Morogoro, Tanzania. My name is teacher Ramadan Kideghesho, teaching chemistry. Today, I will take you to one of the Form 3 topic which is called the volumetric analysis. In this topic of volumetric analysis, subtopic which must be covered including the following. The first one is standard volumetric apparatus. The second one is standard solution. The third one is volumetric calculation. And the last one is application of volumetric analysis. Now, starting with introduction to volumetric analysis. Students, can you define volumetric analysis? Good try. By definition, you can say volumetric analysis is the process of determining the amount of substance in terms of volume and concentration of reacting solution. So when we are talking about volumetric analysis, we more deals with the volume and concentration of reacting substances. This is the quantitative determination of amount of a substance in terms of volume and concentration. So in volumetric analysis, we deal with the volume of a solution. That's why this quantitative determination is called volumetric analysis. So the amount of a substance present in a solution is determined in terms of volume, and the unit is, we use here liter or decimeter cube, or concentration, and the unit of concentration is gram per decimeter cube or mole per decimeter cube, depending on the type of concentration. So the volume should be in liter, or in another word you can say decimeter cube, and the concentration can be either a mass concentration, which is unit is gram per decimeter cube, and or molar concentration, the unit is mole per decimeter cube. Now, let's discuss concentration. So, students, can you define concentration? Good. By definition, you can say concentration is the amount of a substance present in 1 liter or 1 decimeter cube of a solution. Concentration is the amount of a substance present in 1 liter or 1 decimeter cube of a solution. Now, how many types of concentration? Students, can you mention the types of concentration? Okay, we have 2 types of concentration. The first one is a molar concentration. Another name can call it molarity, and the second one is a mass concentration. So we have a molar concentration or molarity, and the second one is a mass concentration. Now we're going to discuss one after another, starting with the molar concentration or molarity. So students, can you define molar concentration? Okay, molar concentration by definition you can say is the amount of a substance in mole present in 1 liter of a solution. Molar concentration or molarity by definition you can say is the amount of a substance in mole present in 1 liter of a solution. And mathematically, molarity is equal to the number of moles of a substance divided by volume of a solution, and the volume should be in decimeter cube. So the unit of molar concentration or the unit of molarity is mole per decimeter cube, or capital M, and capital M stands as molarity. For example, we can say 0.1 mole per decimeter cube of sulfuric acid, or 0.1 capital M sulfuric acid. All these are molarity of sulfuric acid. The second type is a mass concentration. Students, can you define mass concentration? Very good. By definition, you can say mass concentration is the amount of a substance in gram present in 1 liter of a solution. Is the amount of a substance in gram present in 1 liter of a solution. And mathematically, mass concentration is equal to mass of a substance, and it should be in gram, divided by volume of a solution, and it should be in decimeter cube. For that case, the unit of mass concentration is a gram per decimeter cube. For example, we can say 17 gram per decimeter cube of sodium hydroxide. Now, question. The question can say, calculate the molarity of solution contain 0.05 mole of potassium hydroxide in 80 centimeter cube. So here in this question, you have been given the number of moles of potassium hydroxide, which is equal to 0.05 mole. And you have been given the volume, which is equal to 80 centimeter cube. So the volume here is given by centimeter cube. So by solving the question like this one here, you have to convert the volume to decimeter cube, then go through calculation. So from the formula which I have explained earlier about the mass concentration and molar concentration, it's my hope that you can calculate this question, students. Another question says, what is the mass concentration of 10 gram of sulfuric acid in 2 decimeter cube? Here also you have been given a mass of sulfuric acid, which is equal to 10 gram, and you have been given the volume of a solution, which is equal to 2 decimeter cube. So, students, can you calculate this question? It is very simple. I have already discussed the formula, which can take you through the calculation of this question. Okay, now let's discuss another thing which is very important. The relationship between concentration, molar mass, and the molar mass of a substance. Relationship between concentration and the molar mass of a substance. As we have already discussed, we say that the molarity is equal to mole divided by volume. Molarity is equal to mole divided by volume. But the number of moles always is equal to mass over molar mass. For that case, molarity is equal to mass over molar mass times the volume. If you want to obtain the molarity, we substitute the formula of mole to number of moles there. So the molarity, it will be equal to mass divided by molar mass times volume. Now, the mass concentration is equal to mass over volume. We have already seen. Mass concentration is equal to mass over volume. By substituting there, so the molarity will be equal to mass concentration divided by molar mass. So this is the relationship between the molarity and the molar mass. So if you take this formula here, if you have been given maybe the molarity and the mass concentration, then they ask you to calculate maybe the molar mass, you can use this formula, that molarity is equal to mass concentration, then you divide it by molar mass. Thus, the relationship between molarity, mass concentration, and the molar mass is given by the formula molarity is equal to mass concentration divided by molar mass. Sometimes you can be asked to calculate the mass concentration of 0.1 molarity of sodium hydroxide. Assume that you have been asked to calculate the mass concentration of sodium hydroxide, given that you have the molarity and the molar mass. And the molar mass always can be calculated through calculation, as you know, that the sodium hydroxide is a compound, so you can calculate the molar mass of sodium hydroxide. Now, the question says that to calculate the mass concentration, and here you have been given the molarity, which is equal to 0.1 molarity. So, through calculation now you can calculate this mass concentration by using the formula molarity is equal to mass concentration over molar mass. So here in this question, here you have a molarity of sodium hydroxide which is equal to 0.1 mole per decimeter cube. Also, the mass concentration of sodium hydroxide can be calculated by sum up the atomic mass of the constituent element of the compound. And in sodium hydroxide, the sodium is 23, the oxygen is 16, and the hydrogen is 1. So if you sum up, the answer is 40 grams per decimeter cube. Now, by using the formula, molarity is equal to mass over molar mass. Now we make subject a mass concentration. So the mass concentration will be equal to molarity times molar mass, which is equal to 0.1 mole per decimeter cube. Then you multiply by 40 grams per mole. By multiplying, the answer will be equal to 4 grams per decimeter cube. So through calculation, you can obtain the mass concentration of sodium hydroxide equal to 4 grams per decimeter cube. Another question. The question says, calculate the molar mass of 10.6 grams per decimeter cube of 0.1 molarity of X carbonate. Identify element X. Here in this question, you have been asked to calculate the molar mass. And what you have been given here, you have been given the mass concentration, which is equal to 10.6 grams per decimeter cube. Also, you have been given here the molarity, which is equal to 0.1 capital M or mole per decimeter cube. And the compound here is X carbonate. So the X element is unknown. So to calculate the question like this one here, remember you have the mass concentration. Also, you have the molarity. The mass concentration, which you have been given here, is 10.6 grams per decimeter cube. The molarity is 0.1 mole per decimeter cube. So, by using a formula, the molar mass will be equal to mass concentration divided by molarity, which is equal to 10.6 grams per decimeter cube. Then you divide it by 0.1 mole per decimeter cube. So the molar mass of X carbonate will be equal to 106 grams per decimeter cube. So this is the molar mass, 106 grams per mole. This is the molar mass of X carbonate. Another is to identify element X from X carbonate. Now, from X carbonate, we have obtained the molar mass of X carbonate, which is equal to 106 grams per mole. To calculate the, to identify element X from X carbonate, we sum up the atomic masses of constituent elements of the compound. And here we have element X, which is unknown, and also we have carbon, and also we have 3 oxygen. We have 2 X, we have carbon, and we have oxygen, which will be equal to 106 grams per mole. For that case, if we sum up, it will be 2X plus 12, which is the atomic mass of carbon, plus 16 times 3, which is a atomic mass of carbon, and the number of carbon is 3. It will be equal to 106. By sum up, then the value of X will be equal to 23. For that case, the atomic mass of X is 23, and the element X is sodium. Element X is sodium. We have already identified element X. So the element X can be identified by using a molar mass. Now, let's go to the first subtopic, which is called the standard volumetric apparatus. Standard volumetric apparatus. So the following are common laboratory apparatus used for volumetric analysis. The following are common laboratory apparatus which are used for volumetric analysis. The first one is the pipette, and the function of pipette is to measure the exact volume of liquid. The second apparatus is the burette, and the function of burette is to measure the accurate volume of liquid. So pipette and the burette, all these are used to measure volume, but the pipette is used to measure the exact volume, and the burette is used to measure the accurate volume of liquid. Another apparatus is called the measuring cylinder, and the function of measuring cylinder is to measure the volume of a solution, but not very accurate. This one is used to measure the volume of a solution, but not very accurate compared to burette. Another apparatus is the volumetric flask, and the function of volumetric flask is to make up the solution to a total final volume. This one here is used to make up a solution to a total final volume. I mean that the volumetric flask, which can either, there are some which can measure maybe 100 mils, others can measure 1,000 mils. So this one is used to make up a solution to a total final volume. Another is a conical flask, or in another name we can call it a titrating flask. So the function of conical flask or titrating flask is to mix solution during titration process. So the acid and the base, which are solution, which are going to be mixed there, are mixed in conical flask or titrating flask. Another is a wash bottle, and the function of wash bottle is used to store a distilled water. So this one, wash bottle, is used to store a distilled water. Another is a reagent bottle, and the function of reagent bottle is to store chemicals, to store different chemicals, either acid and base and others chemicals. Another is a spatula. The function of spatula is used to scope powdered or crystalline chemicals. If you want to scope powder, we use a spatula, powder chemical or crystalline chemical. Another is a retort stand. The function of retort stand is used to hold or to support apparatus such as burette during titration processes. So during the titration process, we support the burette by using a retort stand. Another is a beaker, and the function of beaker is to hold solutions. So this one here is used to hold solution. Another apparatus is a watch glass, used for holding powdered or crystalline chemicals that are being weighed. During weighing processing, we use a watch glass to hold powdered or crystalline chemicals. Another apparatus is a dropper, and the function of dropper is to add liquid drop by drop. This one is used to add liquid drop by drop. And here in the titration process is a indicator. Indicator is the chemical or is the liquid chemical which are added drop-wise in acid and base solution. So these which I have mentioned here are apparatus which are used during a titration or during the volumetric or during the titration process. And this point here marks the end of my presentation. You were with me, teacher Ramadhani Kideghesho, a teacher of chemistry. Thank you for listening. Welcome again.